Okay, great. Well, welcome everyone. My name is Dev Rat. I use he, him pronouns, and I'm an associate dean of admission here at Reed. Really excited to be moderating this session with you to learn a little bit more about the math and statistics program here at Reed. Kyle, I'll pass over to you to introduce yourself.
Okay, thanks a lot, Dev. So my name is Kyle Ormsby. I am the chair of the Math and Stats department, and I've been at Reed for about 10 years now. So I'm excited to welcome everyone here and answer questions, and we'll also have a short presentation just to kind of ground what the program is about. And with me is a student, Amelie. Amelie, do you want to introduce yourself?
Yeah, hi, I'm Amlil Mahmood. I'm a math senior. I'm also an English minor. But that's not what we're here to talk about. I'm currently thesising, so if you have any questions about that, I'm here to answer them. But other than that, student experience, I'm here to answer.
I do like that you mentioned you are an English minor because I think it really paints a picture about how interdisciplinary Reed students are, right? You can be a math major and an English minor.
Awesome. So I'm going to go ahead and open up this presentation and share it. So I trust folks can see this right now. And yeah, so Amelie and I are here to answer questions. And I think one of the most common questions that comes up is just what's the curriculum? What kind of coursework should you expect to do if you choose to do a math major at Reed? And the curriculum for the sort of straight math major is listed here. You can see that calculus flows into Intro to Analysis, which is a prerequisite for linear algebra. And continuing along that top horizontal there, we also have vector calculus and real analysis as part of our core courses. In parallel with that, as a math major, you would also take discrete structures, Math 113, and then also abstract algebra, which has both 113 and 201 as a prerequisite. So those are sort of the core components of the curriculum. I think what really distinguishes it is that with the exclusion of Math 111, calculus, starting in 112 or 113, these are all proof-based courses. So the curriculum here really focuses on getting under the hood and understanding why and how mathematics works. Um, Once you get through these courses, you'll also take some upper level electives, and the names of those are mentioned in the bullet points below. I'll note that those topics courses in the bottom right, those are offered either every year, every other year, and the actual topic covered changes. So you can actually take those multiple times for credit. We also have a concentration in statistics, which this flowchart is a little bit more complicated. There's a lot of choose your own adventure to this major. But if data and data science and statistics sounds interesting to you, there's sort of an alternate track through the math major where, for instance, you don't have to take abstract algebra, but you do have to take some of these stats courses, probability, mathematical statistics, etc. Um, there is another flavor of mathematics that many students engage with, which is our Math CS, computer science standing interdisciplinary major. And this combines some of the best and most interesting parts of mathematics with the computer science curriculum. So I won't read through this in detail, but if there are questions later, I can always go back to these slides so you can look at the flow chart. Um, I'm gonna mostly skip past this. These slides are normally ones that I share with admitted students who are here on their first day of class or during orientation week. But it is, I think, a key component of the department that we have a really sort of inclusive and welcoming environment. If you visit campus and go up to the third floor of the library annex, the first thing you see when you get off the elevator or the stairs is the lounge where students hang out. There's a whole wall that's a chalkboard where you can work on problems with peers. A lot of sort of collaboration and tutoring and stuff happens in that room. Sometimes people take naps on the couch, but math gets done in a very active and fun way. There is a lot of faculty contact with office hours and being able to make appointments and learn more from faculty in that one-on-one setting. And there are also a lot of support structures in place, both with tutoring and the Math Help Center and other resources. And then I think Amelie is going to share a little bit about sums, which is a distinctive part of how faculty and students engage with each other.
Yeah, so one of the great things about Reed is how small of a school it is. So you have a lot of connection with your faculty. But a more formal way that you're able to communicate with the faculty in the math department is through a student group called SUMS. We do two main things. The first part is like liaison work. So if you have something that you think would make the math department more inclusive or more helpful to students, you're able to talk to SUMS about your idea. We can pitch it to the faculty. We can kind of come up with ways for the faculty and students to talk about things like that and act as liaisons. The other part is we do social events. So we do the hikes. We have student colloquium every other week, Ren Fair softball. If you haven't heard about Ren Fair, it's the big celebration at the end of the year for the seniors, but there's a softball tournament at every year, and there's a lot of departments that sign up to play, and the math department is one of them. And we also do things that are more aimed at like helping with what it the different things you have to face as a math major. So like you're gonna have to take the junior qual. We do qual study sessions. We try to answer questions about the qual and things like that. And that's basically what SUMS does.
Awesome. Yeah. I guess one thing that I noted was a really cool scavenger hunt that Sums hosted recently. So there were all of these clues that led you on a little tour of the department. So lots of fun stuff there. And there's also other aspects of department life. We have a weekly colloquium that we host. So this gives us a chance to bring in mathematicians from other schools who give talks about their research that are accessible to our undergraduates. And we also do a lot of research with our students. So most of this happens over the summer. Myself and my colleague Angelica Osorno have most summers a thing we call the Collaborative Mathematics Research Group, where we have 5 or 6 students working with us on research problems. And we've been very fortunate to, get 1 or 2 papers out of most of those summer programs where we're actually publishing mathematics research with students. We also have a Putnam exam practice sessions, and that's an exciting chance to do some fascinating math. It's a first Saturday in December exam that U.S. and Canadian students can take, and the median score on this exam is either a 0 or a 1 out of 120. So you can tell that folks really enjoy the 6 hours that they invest into that. But yeah, Jamie Pommersheim in the department leads some practice sessions if you're into challenging yourself with those kinds of questions. There are also good study abroad options for mathematics students, both through the Budapest Semesters in Mathematics program in Budapest, Hungary, and also a newer program, the Mathematical Sciences Semesters program in Guanajuato, Mexico. Amelie mentioned qual and thesis. So everyone at Reed takes a junior qual. And that is what sort of certifies you as being ready to write your senior thesis. And the senior thesis has a lot of flexibility in terms of what mode it takes. Some students write research theses, some students write expository theses. Those are both super welcome and interesting. Many students start trying to write a research thesis and end up writing an expository thesis because research is really hard, as it should be. It's just a 1 year process. So, the last bit here is that I'll say thank you for coming, and both Amelie and I are happy to answer questions that you might have.
Awesome. Thank you so much. That presentation, I think, really helped paint a really good picture about what students can expect in terms of courses and kind of culture. I'm wondering, can you maybe elaborate, and kind of either of you elaborate a little bit more on the thesis in terms of like examples of theses that students have done um, in the past?
Amelie, do you want to share what your thesis is about?
I'm happy to do that. I'm finishing up my rough draft right now. So Kyle mentioned that there's a couple different types of theses. I'm working on an expository thesis, which basically means you're focusing on a topic and you're bringing a bunch of different sources together to try and find a way to best write about this topic. I'm doing a little bit of a biology related math thesis. So it's on evolutionary trees. And the idea is that I'm taking this like super pure math topic called algebraic geometry, and I'm using elements and parts from it, like ideals, and varieties, and using those to find a way to create these evolutionary trees based on biological data. And so I'm focusing on a lot of work done in one paper and then working on trying to flesh out more examples and to kind of put together a better vocabulary to make the paper more readable to undergrads. So that's been really cool. Yeah.
Yeah, and I'm currently mentoring three thesis students. One of them is doing sort of an applied piece of work on how a tool called topological data analysis can potentially help with diagnosing neurodegenerative diseases like Alzheimer's using MRI scans, but also some pretty cool math. I have another student who's thinking about kind of the intersection of symmetry and group theory and machine learning and working in a field called geometric deep learning. And then I have a third student who is writing an expository thesis on the moduli space of polygons. So this is kind of fun stuff where if you imagine that you have like a quadrilateral, but the vertices are hinged, then it can kind of take various different shapes. And you can ask, well, how many different shapes does it take? Is there a way to naturally parameterize those? And my student is doing a pretty fun um, visualization of what that moduli space looks like. And I wasn't planning on this, but he recently shared his results with me. I think I'll show you what it looks like because it's really fun. So, do. Okay, so I claim that this is a picture of the space of quadrilaterals, and what these parameters here are the side lengths. And so we're assuming that the side lengths add up to 1. And I'm just going to let one of these side lengths vary. And it turns out that the space of quadrilaterals is always a subset of a torus, like a donut. That's why we see this periodicity in this picture. And depending on the side lengths, there's either some inaccessible configurations where you'd have to like kind of take your quadrilateral apart in order to get to the other thing. That's when there are two components, or sometimes there's only a single component, like that case. So that's what he's working on, and I'm pretty excited to see the final writing on it.
Very great. we have an admission intern who's a math major, and he often tells me, or like to show me some of the work that he's doing on his thesis right now. And he also did the Budapest experience, and I'm often like, I have no idea what you're saying, but the passion that you have is fueling you, and that makes me happy for you. And so that's always great. And I love to get to see the passion that students have for the. I often say that Reed is a place where students get to nerd out on the things they want to nerd out on, and I'd love to see that come to fruition. Kyle, you mentioned that most classes were proof-based. What form does that typically take?
Yeah, great question. So uh, when I talk about a proof-based course, this is both an expectation in terms of how content is delivered and how you're like learning about the material. So instead of being told that, here's a fact, go and use it, pretty much everything is being justified in a rigorous way. So, if you want to know why. When you integrate the derivative of a function, you can just evaluate that function at the endpoints and take the difference. Math 112 is the place where that's going to be fully unpacked so that you know exactly why that's true. Um, there's also then the what we're asking students to produce, and there we're sort of like taking bits and pieces of this content and asking the students themselves to fully understand and exposit why something works that way. There certainly still be some, calculational or computational questions, but it's this sort of conceptual understanding and rigorous proof that's emphasized in the coursework.
And then this is for either of you, but where are you seeing math majors at Reed often go post-graduation, whether that's grad school or beyond, in terms of career paths, where are you seeing math majors go?
I'll jump on that one. And we have our students head in a lot of directions. I'll maybe start with graduate programs, which are certainly well represented among math majors, but still not the majority. You can do a lot of other things. But some of the programs that we've had students go to recently include University of Chicago, UC San Diego, Berkeley, a number of like very strong top level selective programs. We've also had students go to, University of Minnesota and, other places that are very good, but not necessarily at that kind of most selective level. And a lot of them do persist and earn their PhD and go on to get faculty positions. So actually, my second thesis student ever at Reed, Riley Thornton, just came in to give our colloquium talk, and he's currently a postdoctoral scholar at Carnegie Mellon. So that was kind of fun to close the loop with him. In terms of other careers, we certainly have students go into things like data science, data analysis. We have students who go on to do software engineering, especially those who have done like a math CS interdisciplinary major or just thrown some CS courses into their coursework. I have a former thesis student who's now an actuary. She underwrites airplanes in Seattle, and other students who have gone on to do work in education, high school teaching, that kind of thing. One of my current thesis students is going to go do an internship with the Museum of Mathematics in New York City next year. So, pretty broad array of things. Um, and yeah, we definitely feel like the major opens up a lot of doors.
Amelie, I'm wondering if you could tell us a little bit more about, from your student perspective, what is the culture like in the math program?
Yeah, I think one of the biggest things for me with the math department is how collaborative it is, especially when you get to the 300 level courses. I think you find that a lot of students love to work together on problem sets, and it's definitely encouraged by the professors to work with other students on problem sets. As long as you, of course, reference who you're working with, you want to make sure you're setting your sources. But that's really cool. And I've been to like office hours with professors where like so many students just want to find a place to work with other students that the office fills up fast and you have to switch to a classroom. So that's a really big thing, and it's a really awesome way to keep you engaged and to make sure that everyone's having a good time in the math department.
And then we have a student in the comment who says that they love studying math. And they want to know what math classes that read beyond the basic requirements would either of you recommend?
I mean, I would recommend all of them. But you know, for right now, I'm teaching our topics in advanced analysis course, which is a really fun opportunity for me. Analysis isn't my specialization, but I've always really wanted to get into Fourier analysis more deeply, and so I'm using that teaching that course as an opportunity to do that. There is a really nice combinatorics class that's offered periodically. There's also a point set topology course that a lot of students take, and that's definitely a cool topic. There's also a topics in geometry course that can hit a lot of different things. I know, for instance, like when Jamie Pommersheim teaches that, he often focuses on like counting lattice points in polytopes, which is a really cool subject. When I've taught it in the past, I covered hyperbolic geometry. And yeah, so I think all of those topics courses can be really neat because oftentimes they're really small, like probably like no more than 10 students, and the faculty there are really like pushing in an interesting direction to think about cool stuff with students.
And then for someone with, coming into Reed who might already have some college level proof-based math classes, or, I'm going to add to this question, AP math, IB math, some dual degree type math class experience. How does math placement work? Is it possible to skip requirements if they've already received credits for some of those math classes?
Yeah, great questions. So we have placement conversations with students over the summer. Those are actual math department faculty meeting with students one-on-one to kind of gauge where they are mathematically. Sometimes that's not necessary, right? If you've got AP credit, a 4 or 5 on the AP exam for calculus, either AB or BC, then that will earn credit for Math 111, and we'll almost always recommend that you continue on into Math 112 or Math 113. There's also IB credit in a similar fashion, although I can't remember that off the top of my head. Um, for cases where we do somewhat frequently have students come in where they've taken some classes at another college or they have a particularly rigorous high school program. And that's where those placement discussions are really important so that we can just one-on-one gauge where a student is and set them up with a plan. And it'll often be a plan where like, all right, why don't you start in 112 and then take 201, and you had that multivariable calculus course. It's not quite everything we do, but if you can kind of learn some of that over the January break and answer some questions, then we'll waive that requirement. We're pretty responsive. It's one of the kind of nice things that we can do at a small school that in a larger place it might be hard to sort of individualize things in that way.
Great. And Kyle, what are your recommendations in terms of math classes that students should be taking in the high school level in order to prepare for the math department here at Reed?
Sure. So we have students who have never taken calculus, who come in and start in Math 111 and end up being very successful math majors. I had a thesis student a couple years ago who is now a graduate student at University of Pennsylvania who started in exactly that way. Um, the of course, if you have the time and energy, I think it's great to explore as broadly and deeply as you can as a high schooler. And so, if you do take a calculus course, then you'll likely be able to start a little further in the curriculum here. But I know a lot of high schoolers are sort of deciding between like AP Stats and AP Calculus. I think that's an important one to think about. We don't give AP credit for statistics. The Math 141, our Intro to Probability and Statistics course, is pretty different from the AP curriculum, and in particular, it uses the R programming language throughout to produce data analyses and visualizations. So maybe take that into account when you're making those decisions, but we'll definitely meet students where they are.
And how many math classes do math majors typically take per semester and then per year?
Amelie, do you want to take that one?
Yeah, so I've definitely taken at least one math class every semester I've been at Reed. And I'm counting thesis as a math class, even though it's set up a little bit differently than you would take like a normal math course. Um, I haven't taken more than two in a semester, so that would be if you take two in 2 semesters, it would be four across a year. But I know a lot of people who have taken three. Um, it gets a little bit difficult to take three, I think, because then you're just thinking about math all the time, and sometimes it's nice to get your distribution requirements out of the way a little bit. But there's so many math electives that you can really like, if you're just really, really interested in taking those electives, I think you could take three a semester if you really want to.
Awesome. And for those of you that are not familiar, Reed does have a distribution. We have distribution requirements. It's our closest thing to like core curriculum here at Reed. And so there's essentially three groups of classes that are you'll take classes from, and you'll take three classes from each of these groups. And you get to pick the classes from the different groups that seem fun and interesting to you, and get a lot of that flexibility in that process. Are there any student clubs or groups that are related to math here at Reed?
So the big one is sums, which was mentioned in the presentation. Although that one is it's not exactly a club. I mean, it's also a job. And so those the students who are the sums members actually apply for that, and then are hired by the department. But they do organize a bunch of activities for math students. So there's a student colloquium that runs on Mondays where the students give talks to each other. And then there's also all the sums activities that end up happening, like our hike in the fall and the softball team and those sorts of things.
What advice would you give, Amelie, sorry, to a student who is considering Reed? You know, they're potentially an admitted student, maybe they're currently a high school senior or a junior, and they're looking at colleges. You know, from your own experience when you were looking at colleges, what advice would you give to students?
I think the biggest thing for me when I was applying to colleges was that it was important for me to have a smaller school where I knew that I would be able to ask for help when I needed it. So I think that when you're considering colleges, think about like how much you want to be able to talk to a professor. All of our classes are taught by professors, which is really awesome. Um, and like if you want a smaller environment where you're kind of taking these classes with the same people over 4 years and you're getting to know them better and better, um, versus if you do better in an environment where maybe you're meeting a lot of new people every year. That's not exactly the case here, but you definitely get really, really close with the people that end up being math majors with you. And I think that was really important to me. And that ended up being the case, which was really awesome.
And then, and this is for either of you, what sets apart Reed's math program compared to other institutions?
Yeah, I think it's really unique to have so much of the curriculum be proof-based and conceptual the way that we have it. We don't have, sort of math courses for engineers or math courses for, not math majors, which might sound scary if you're not planning on a math major. But it's really a trademark of most of the courses at Reed that, the students who come here tend to be academically very ambitious and very excited to learn things sort of on their own terms. And so that's where our emphasis is as a faculty and in the curriculum. And we feel like students really have a right to know. They really ought to be able to dig in and understand why things work. So a lot of curriculum at other schools, you might not have an intro to proofs course until maybe your sophomore or even junior year, whereas at Reed, you're really diving into that right away. And then I think just the amount of faculty contact and chance to really work with your professors to pursue whether it's your latest problem set or even a research problem is very unique.
So this one I did have to Google because I did not had not heard of this, but do math majors take the Putnam exam? And if so, is it fun practicing and studying for it, or what is that process like?
Yeah, I don't think it's like a majority of math majors who sit for it, but some people get into it, and I know that Jamie runs the practice sessions, and as far as I'm concerned, like any spot time doing math with Jamie is a win. Yeah, I think that if that's the kind of thing you like, then there's going to be a community there to do it with. If you'd rather skip the competition aspect then you won't lose out on much either.
Awesome. I am not seeing any more questions in the chat box, so I think I'm going to end us with one last question, and this is going to be for the both of you. What's your favorite part about being here at Reed and being a part of the Reed community?
Do you want to go first, Amelie?
Yeah, that's a really big question. I think one of the big awesome parts of being at Reed are the like really fun student traditions that we have. We have Hue and Play, we have Ren Fair, there's pool hall competitions every Thursday. There's just a lot of really fun, quirky things going on here. And I think if you're into like weird things like that, if you want to see people do a remix of the humanities curriculum as a play in front of all of the freshmen, um, then you found a good place to go. And I just really enjoy the effort that the students put into kind of keeping these traditions. And it's just a really awesome part of the student experience.
Yeah, and I'm gonna give two favorite things. One is the students. I feel super privileged to work with Reedies as a faculty member, to kind of get to show up in the classroom and know that everyone there like really wants to learn and is really excited to dig into the stuff that I have to share is just an incredible privilege. I'm always impressed by the creativity and dedication of the Reed students, and that's an awesome thing to get to engage with. My other favorite is the canyon. So there is this really great natural space that runs through campus. There's a couple of bridges that go over it. There's a trail system down there. There's a fish ladder. And I have seen owls and cranes and herons and nutria down there, which is like a beaver, but it's scary. And yeah, it's a really special place. There's a canyon day that's held in April. It just happened, where the community pitches in and like goes and helps clean out invasive species and take care of the space. So yeah, those are my two favorites.
Awesome. Well, a huge thank you to you, Kyle, and to you, Amelie. I appreciate you both taking time to tell us a little bit more about the math and statistics program here at Reed. And for the folks that were joining us for this session, I hope you found this helpful and useful. Thank you all so much for being here, and you all have a great rest of your day. Bye, everyone.